opportunities. So let's please welcome Lorena Mesa. She'll be giving the talk Escuincla babosa, creating a telenovela script and 3 deep learning frameworks.
Excellent. Okay, can you all hear me all right? Very cool. I naturally am a loud person and use a lot of hand motion, so this will be great because I think it goes with the topic pretty well. So yes, if you were staring at the name of this talk and you're like, I don't think there's English in some of this, you are correct. You're in the right place. So Escuincla babosa, creating a telenovela script and 3 Python deep learning frameworks. Side note, I will be actually on some of the slides, there is a URL that you can actually follow along with the slides. And I do actually have all my content linked to the GitHub repository that has this code. And there's a surprise of another GitHub repository at the tail end. So, who am I? Hola, soy Lorena Mesa. Puedo hablar en inglés or español, but I will obviously be talking in English for this talk. It is not PyCon charlas. So, the topic, I personally am just really interested in deep learning. I hear the term deep learning and I'm like, what's so deep about this learning? So I'm really just kind of curious about this topic. And I also really love telenovelas. So when I was thinking about a topic, it felt like a very big win-win for me. So why not? Why not? But actually, more practically, I actually work as a data engineer at GitHub, and I sit between 2 teams in the data org. My team's name is Software Intelligence Systems, which is a little bit of a mouthful. SIS for short. And the teams that I work with are our semantic code team and our machine learning team. Our machine learning engineers are increasingly talking about different deep learning techniques and using GPUs, and a lot of these kind of techniques I hadn't used before. So why not marry my interest and try a little toy session and see what I can learn about deep learning and share with you all in a PyCon talk. I do some other work in the Python space as well. I'm in Chicago. I help run PyLady Chicago, and I'm also on the Python Software Foundation Board of Directors. Yay! Yeah, if you do have any questions about those things, again, you can find me later. So I'm a bit curious how many of you may have seen some of these headlines floating around. Oops, sorry about that. Let me go to the next slide. OK, excellent. Did anyone see this headline floating around about this AI-generated script starring David Hasselhoff? No? OK, you should watch it. It's this really interesting and absurdist 8-minute short. And the creator of this, Ross Goodwin, who is a creative technologist in Google's Artist and Machine Learning program, actually used a RNN, a recurring neural network, to actually generate all the lines that were in this short for David Hasselhoff's script. The short is quite interesting. It's very ephemeral. It's not quite clear what's happening. But when I first saw this headline, it actually got me thinking about the intersection of art and technology. And this was something I never really had thought about before. What happens if we can maybe automate the idea, the creativity process? What does that actually look like? Another place that I kind of started seeing this floating around, as one does, lots of conversations on Twitter. Specifically, this is a screenshot from a chat that was March 2018, wherein someone alleged that they took all of the scripts from all the scripts of the various Saw movies, and no, I do not know how many there are, and apparently developed a neural network and allegedly trained it for 1,000 hours, whatever that means, to generate this script. And this script is supposed to be a horror script, and in the script, that first line, it says, a sexy woman, Becky, sex woman, is covered by a bed. She's in a whale, but doesn't know she's in a whale. And it's a very confusing piece of text. The part on the right-hand side that kind of continues to go into this a little bit starts talking about how this is a really interesting application of neural networks to try to create and automate the idea with text generation of movie scripts. However, they do start asking questions about why are there words in the vocabulary used in the script, including such language as Trump and whale. The person then goes on to critique to say, actually, nowhere in the Saw movies are these 2 words appearing. And if you know anything about neural networks, and by the end of this talk you will a little bit, that can be a little problematic because as the neural network is learning, it learns from the corpus of text that you provide it. So if you're allegedly providing it the Saw scripts and it's coming up with words it had not ever seen before, can we say this is actually an AI-generated script? I don't know. Either way, I think this thread is very interesting, and it started poking a lot of questions and made me want to actually try my own example. The whale did that. It became a meme. You can go find out more about this script. But there's a lot of people that are starting to think about what is the intersectionality of creativity and technology. So you might be asking, why telenovelas? Also, what in the world is a telenovela? Well, you came to the right place. I'm here to inform you about one of the most epic meltdowns in a telenovela that has ever happened. So do I have any telenovela fans in here? Yes, okay, that's exciting for me. So maybe some of you remember this one, Maria la del Barrio, which is a beloved Mexican telenovela from the 1990s, I believe specifically 1995 to 1996, with like 195 episodes. But this scene, and the images might be a little hard to see, but this scene includes some of the characters of where we get the beloved phrase, Escuincla babosa, which is in the title of this talk. So we have on the top two, we've got a love-struck couple. We have Alicia to the left, and we have Nandito to the right. And the main character who's shown on the right-hand side, and also in that third panel at the bottom, that is Soraya. So she is our main character of this telenovela. And Soraya, she's got some complex history going on. So she's the stepmother of Alicia, and then Nandito is her ex-husband's son. Right. and the thing here is, Soraya is still desperately in love with Nandito's father, like to the point of, maybe there was like a restraining order. So she's desperately in love with Nandito's father, and she's stuck in a marriage though, where she's got this daughter, Alicia. So she happens to walk into the room where Alicia and Nandito are starting to express their love for one another. Nandito very tenderly says, may I, Alicia, please have a kiss? And as they're leaning into this moment, in comes Soraya. And Soraya is like, what is going on? I don't understand. Because for her, this shatters, I guess, her master plan to get back with Nandito's father. Essentially, she then screams and calls Alicia Escuincla babosa, which kind of means you spoiled rotten brat, in nice speak. And what then ensues is the most epic fight, I guess we can call it. There's a lot of kind of air slaps, and you can very, very specifically tell that there's not any contact happening. There's people like diving over beds to protect one another. Some random gentleman in a suit walks in and is like trying to break up the fight. His character is in no way, shape, or form explained as to why he's there. And then the nanny here, she walks in, and what that says in Spanish here is, this woman is, she's got problems. She is possessed by the devil. So this scene and all this kind of trope of like love and complex family relationships and the idea that we all have this trauma that's near and dear to our heart, that leads us into what a telenovela is. So Jorge Gonzalez, in talking about telenovelas, he's a sociologist, kind of commenting on the impact and social phenomena of telenovelas, basically says they are melodramas. And these are serial melodramas. You get increments of 25, 30 minutes, maybe 5 times a week. But what happens here, because it is a stable relationship that you're making with the audience, people become very passionate and very connected with these narratives. To the extent that when we talk about telenovelas, there's about 2 billion people worldwide who consume telenovelas that are from Latin America. That's about like a third of the world population. So that's a pretty sizable number. And if you want to know more about why telenovelas are a big deal, here's some stats of some of the viewing and patterns of viewing of Latin American telenovelas. So Latin American telenovelas have been viewed in over 100 countries. They have generated over $800 million in marketing on various telenovelas in a 5-year period. I believe that stat is 2010 to 2015. And just generally speaking, this is a global phenomenon. So in breaking down the arc of a telenovela, because if we want to try to emulate and create a telenovela with a neural network, we need to understand what it is we're trying to create. So back to kind of thinking about that kind of relationship and things that pop up. One of the things that's interesting about telenovelas is this idea that there's not really any cliffhangers or kind of open-ended stories. Dr. Rios, who talks about telenovelas and kind of understanding their social impact, specifically says that at the end of the telenovela, things have to be cleared up. So in our Maria de la Barrio, for example, if we have the character Maria and we want to know what's happening, she would hypothesize and say, our audience doesn't want to worry about Maria. We don't want to know if she didn't find her true love, her true mother, her true father. We want all those answers. So unlike English soap operas, which I think some have been going for more than 15, 20 years. What happens with telenovelas is you have a fixed melodramatic plot line. And yes, it's going to be lost loves. It's going to be mothers and daughters fighting. It's going to be long-lost relatives. It's going to be love found. And maybe as quickly as you found that love, something happens where that person is shipped away and we don't know what happened to them. Maybe it's the guy in the suit. He's from another telenovela. I don't know. But our telenovelas have a finite beginning and end, and they're generally tied up with a very big happy element at the end. So for example, the world's largest wedding. If you watch Casa de las Flores, there's kind of some of that maybe that's being built up to. But yes, there's always this idea we've got a fixed arc, a lot of intricate kind of heart-wrenching moments, but it's going to wrap up with something happy that we can all feel good about and move on with our lives and not wonder what happens to these characters. So if we're thinking about examples of telenovelas, let's take a look at some of the ones that are available to us in Spanish. So this is Kate del Castillo, who I swear, I think she's my role model in life. She's fantastic. If any of you watched that documentary about talking with Chapo, who's a narcotraficante, she was doing that with Sean Penn because that's what she does in her free time. But she's very famous. She's been in many telenovelas, and one of the ones that is most known is La Reina del Sur. So that's an example of one that is really, really popular in Mexico. And then many of us may know Yo Soy Betty la Fea, because actually some of these telenovelas have crossovers in English. So the ones that I looked at, because again, we're predominantly an English-speaking population, I looked at popular telenovelas in Spanish, looked for their English crossovers, and then worked with that text. So Queen of the South, which is actually on USA, talks to us a little bit about that narrative with Kate del Castillo. In this one, in the Queen of the South, essentially what we have is the character who becomes the most prominent drug lord trafficker in South Spain after she has to flee Mexico because her beloved is actually captured by the cartel that's pushing drugs in that area. So of course, as one does, you relocate to another country and then you start your vast drug empire. So that one's going to have love lost. It's going to be a thriller. It's going to be a drama, and it's going to be high emotional kind of action impact. And then with Ugly Betty, what we have is more or less a rom-com. This actually started in Colombia, and it's had, I think, 3 or 4 crossovers to different Spanish-speaking markets, starting in 1999 in Colombia. But essentially what we have is a character, Beatriz, who works in the fashion industry and is considered ugly because stereotypical things like she has braces and she has glasses and things that I have all worn in my life. But anyways, it's all about the story about her struggles working in the fashion industry and trying to find love. And then Jane the Virgin actually, I know I said I looked for popular crossovers from Spanish to English, but for this one, because I think there's enough comfort and knowledge for people of what this one is, Jane the Virgin is actually a satirical melodrama, but it's fantastic because essentially we follow Jane, who is a virgin, who after visiting a doctor's office somehow becomes artificially inseminated and becomes pregnant. So she's a pregnant virgin, and then various things that unfold afterwards and how she finds love or how she doesn't find love leads us into this complex story that is Jane the Virgin. So in thinking about telenovelas, we understand a little bit of the arc. We understand that's a melodrama. We understand that it has finite end. We understand it's going to wrap up with something happy, and we understand some of the tropes that may be employed. So now how can we start applying this to deep learning? When we think about machine learning, and I'm not sure if many of us in here do machine learning, some of the things that you may think of are some of the language that's provided to us by the founders of this discipline. So Arthur Samuel, who actually coined the term machine learning, actually provides us with this language saying that machine learning is a field of study where computers have the ability to learn without being explicitly programmed. So there's this idea that there's something that's not requiring us to actually have some intent or some purpose. So that is where we kind of can start with machine learning. Now, as we see here at PyCon, there's many various talks that may talk about data science or machine learning, and this is a very, 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 very vast space. So if we were looking at, for example, technology and tools, we may see things like Python. We may be talking about things like Spark or Julia or other scientific programming languages. If we're talking about the kind of problems we can solve with machine learning, we'll see the problem categories on the bottom left-hand side. We might be doing classification, clustering, optimization kind of problems. However, what we want to focus on is this idea of a subfield. So when we talk about deep learning is a subfield. It's a type of machine learning and is alongside other categories, such as maybe ones you may have heard of: supervised, unsupervised, semi-supervised. So to broaden on that definition of machine learning and kind of challenging us to think about how we can actually have a deep learning model that can actually generate an ML script, we probably need to reconceptualize what machine learning means. So this is a great definition given to us by Tom Mitchell. And Tom Mitchell, the former chair of the computer science department at Carnegie Mellon, who wrote, I think, the quintessential book on machine learning, published in 1997. It stands up really well. I highly recommend reading it. Basically says, when we think about machine learning, it's not so much that it's a program that isn't explicitly programmed, but instead it's that there's something that we want to accomplish. So if we're thinking about a computer program that's said to learn, let's think about it in this framework. We have some objectives, so we have a task that we want to accomplish. And in order to accomplish that task, we need to be able to provide it with some ability to understand what that task is. So we have a task, and then we provide it some ability to understand what that task is, which is the experience. And then as that program continues to attempt to do that task, we can develop a performance measurement to understand how it's improving over time. So this language gets us a little bit closer to thinking about what machine learning is when applied to deep learning, but it doesn't get us all the way. So the trend with machine learning over time, and it's kind of wild to think that in the 1950s and some of these algorithms that we're talking about today, naive Bayes, for example, this is not new math. This is not new algorithms. These are things that have been out there for 20 plus years. But what we're seeing in the trend of the world of machine learning and what does it mean for a machine to learn, we start with this realm of artificial intelligence. We move into machine learning, which is, again, that idea of a program not having to be explicitly programmed to do that task. And then we move into this world of deep learning. And we start hearing about these things called neural networks, which sounds very sci-fi and very unclear what that is. To frame it a little bit more simply, if we were to think about what it means that this evolution from AI to deep learning, we can say that an example of an artificial intelligence program is a door sensor, because it's able to adapt to its environment around it. With a machine learning, we can say an example of a machine learning program is our spam filters. We all know it. We see it in our various email inboxes, the idea that we know spam when we see it. Can we teach an algorithm how to do that? Yes, we can, and we've done that with machine learning. Now, if we're moving into the realm of deep learning, what we start getting into is this idea of using these neural networks that drives its own learning. That is the engine by which the learning is empowered. And if you see on this right-hand side here, this project is called the Deep Dream, which came from Google Research, wherein they were providing an image of an object to an algorithm, and with the desired intent and output to say, tell us what you see in this image. So what we start seeing on the other side is if we provided, let's say, an image of an apple, it's like, okay, I understand that this is an apple, but what other images do I see in it, and what can I infer from this image that I'm seeing? So kind of flipping it a little bit on its head and getting into the realm maybe of, do androids dream of electric sheep? That's where we start saying, okay, we're going to give you some idea, some definition, but using this neural network, we want you to drive your own learning. So if we were thinking about an example of applying deep learning to, let's say, a classification problem, if I had something like a flashlight and I wanted it to respond and learn from audio cues to turn on, we could say, let's say I want to have a flashlight that if I say the word dark, it turns on. Well, with a deep learning implementation, it wouldn't just have that fixed understanding of saying, okay, dark maps to turn on because this is the task of bringing light to the world, but instead it might understand other cues, other verbal cues that I might be able to supply to this model. So I might say something like, I can't see, or the light switch won't work. With a deep learning kind of implementation, the neural network would be able to learn and infer these other kinds of words that may fill in to suggest that there's an absence of light, to suggest that the area around you is dark. So this learning, again, that happens, the brain, which is that neural network, happens with an activation method. So moving now back to telenovelas, there's a type of problem called text generation that we're gonna be looking at. So text generation is sequence processing, and sequence processing has a lot of applications in the world of deep learning. We can use it for video processing, price modeling, and yes, text generation. Essentially what we want to do is there's two approaches that we can have. Using language, so actually using a body of text, we can say, we want you to look at the individual words that are in this text to actually generate some text on the other side, or we can actually develop the deep learning model to actually look at the individual characters that are provided in the corpus that we're working with. Either way, given the text that we provide to the sequence processing model that we use, what it's going to start trying to do is approximate the relationship of what words mean to what the relationship between one word is to another, and then as it tries to understand the relationship between words, try to think about how it is that it can build its own patterns and generate its own vocabulary that kind of models the relationships it sees in this corpus of words that we provided. So I've been using the words neural networks and deep learning a little bit interchangeably. And while I want you to understand that there are these artificial neural networks, what essentially deep learning is, it actually makes use of several neural networks. And when we talk about neural networks, the power that drives a neural network is the neuron. So the neuron here it's got three parts. We have the inputs, we have the weights, and then we have the activation function. So essentially what's happening is our words are going to be the inputs, and we're going to represent those as either words or as either characters. We then apply an arbitrary weight to it, and then as it runs through each layer in our neural network, it's going to start trying to approximate that relationship to understand relationships either from word to word or character to character. And then it's going to go through this activation function where, as it's learning these relationships, it starts adjusting those weights to try to find the optimal weight to use to actually start generating a thing, or in our case, generating text. So the activation function, you can think of something like a sigmoid function. So essentially what we have is some kind of function that is a nonlinear function that is going to allow us to actually start doing some math. So if we have a weight applied to a word, let's say it starts at 0.5, but we need to start shifting it either higher or lower based on the relationship between these words that the network is learning, we've got this activation function to help us do that. So when we're training a neuron, essentially what we need to do is these three steps. The neuron takes an initial guess at classifying the sample, and then updates the guess by adjusting the weights, and then it goes ahead and repeats and tries again. So this process is very iterative. And with neural networks, there's many kinds of neural networks that we can use. Feed-forward, radial basis function, or an RNN. And RNNs are good for sequential processing problems, like text generation. And what's really cool about this is that it actually allows us to propagate data back and forth. So as our neurons are all connected, so a deep neural network would be an example of what we have on the right-hand side. Basically, it's a directed graph. We have input going from one node, but also we can move backwards. So using an RNN, insights learned upstream or downstream can move back and forth across these neurons. So if we wanted to make an RNN in Python, how do we do it? Well, there's more than one way, as we like to do. So there's three really popular frameworks: Keras, TensorFlow, and PyTorch. And yes, I'm going to borrow the language from the 2017 keynote, but yes, Python is surprisingly super awesome, or maybe unsurprisingly super awesome at scientific programming. So these three frameworks, when you're thinking about which ones to use, I like to think about questions to help me think about what tool is best for the task at hand. How much technical expertise is needed to start using it? What are your requirements? For example, do you have a certain SLO you have to meet? What's the size of data you're working with? And also, how easy is it to start using the framework? So if we're looking at making an RNN in Python using Keras, we've got these three steps that we're always going to be emulating. Basically, we have to take that text, and we have to transform it either into characters or words. So we tokenize it. Then once we've tokenized it, we generate these hot encodings, which basically gives us, let's say, on the next slide, this actually gives us a nice example. Let's say our corpus is the word bad. And because we've got the letter B, what we would want to do is we've got nine characters in our corpus. Let's say we have other words that introduce these other characters. What we want to do is basically be able to understand and predict the likelihood that for each corpus, for each character in our corpus, to actually say what's the likelihood that this character will appear. So as we generate this hot character encoding, we're going to use that as input to our neural network, and we're then going to pass it through our RNN and basically say, hey, start learning the weights and start coming up with the optimal weight to represent the likelihood of what character you should be generating based on these, again, trying to approximate that relationship in the underlying text, and let's see what we get on the other side. And to train this, we're going to run it through some number of epochs. So with Keras, what we can notice here, for those of you who may have used scikit-learn, we've got a really nice high-level API we can use. Notice how I said sequential processing is a text generation is a sequential processing problem. Surprise, we're going to use a sequential model. So LSTM, long short-term memory, is a type of RNN, again, propagating that data back and forth. This is pretty straightforward because it allows us to pull in the sequential model. We specifically say we want to use an RNN of this type. We then basically add in our data. And then we say, OK, let's go ahead and compile that model. And notice this fit. We're going to have 20 epochs that we're going to train over. And what we want to do is we want to find that optimal weight that we can generate. So Keras has a very nice and user-friendly interface that we can start using. And if you were kind of looking at like what it may look like for that process of running through epochs, well, you can just basically think of a for loop. It's very iterative. If we have 20 loops or we have 1,000, we can start doing things like that. And then when we start wanting to actually use it, we've got that model.predict functionality. So Keras is pretty cool. Now let's look at TensorFlow. Mind you, I did some lifting of this data, so there's some logic that's kind of not captured, but it is actually in my GitHub repository. But again, when we're using TensorFlow, again, we import TensorFlow, and we've actually got an RNN that we can pull in. Unlike in the last case where we've got like this sequential model and we've got the LSTM that's kind of baked in, we're going to actually have to start making and creating our own object to represent the RNN. We're going to be working with tensors, which is, again, a representation of the vector data. And what we need to do then is start writing a definition of the RNN that we want. So notice that we've got the basic LSTM here that we can pull in. But essentially, when we're using TensorFlow, we're going to have a little bit more knowledge about the underlying. We're not given that high-level API interface where it just says, hey, here's the thing out of the box. You actually have to go and take the components and actually start building it yourself. And likewise, then when you're actually optimizing the weights, what you have to do is you actually have to run a session, a TensorFlow session, and notice, again, we have this epoch loop. We're going to go ahead, do n iterations, and then when we find the optimal weight, what happens in both cases is you can export those optimal weights once you found them after running so many epoch sessions. Those weights then, let's say they're in a flat file, you can then import those for later use. So TensorFlow, we don't have that high-level interface. We've actually got to kind of meld some of those components together ourselves, but we understand what we're doing. We've got to build the model, we've got to fit the model, and we've got to train the model. And with PyTorch, PyTorch actually gets a lot more interesting, and you have a lot more flexibility to go in there and build things as you want. So notice here, as we're building our RNN, with PyTorch, notice how we're having to actually build the interface for actually how forward propagation works. So remember how I said data can move forward and backward? Now you are able to actually go in and write that logic how that happens and how you're interacting with these other neurons. So the interface actually is much more low level. And again, when we're training, we have that great epoch loop that we've come to know and love. And also, when we get our output, we can then export that output. To then import to our model for later use as well. So with those three neural networks examples, what actually can we start generating with an RNN using Python? This is some of the most coherent text I actually started developing, which is to say that it is a work in progress. So one of the things I noticed is as I started asking to make longer pieces of text, it just started getting really, really wild. Remember, the whale did that. So some of the more coherent units of text I found was actually getting character strings of about 200. So why is that? Why this kind of feels like it's in line that it could be in a telenovela. Don't threaten me. Do you not understand me? Whoa, 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 right. Like maybe we're making that famous fight scene all over. But in thinking about the tooling that we need to build, think about those 3 questions. How much technical expertise is needed to start with a framework? I've told you that I'm new to deep learning, or relatively new, so I probably want something that's a little bit more beginner-friendly, something that allows me to build a small toy project quickly, and something that has, for me, this is super important, a very, very good, robust user group that gives lots of documentation and lots of examples of how to use it. For my second question, what are my requirements? Well, actually, because I focused on just looking at those 3 English telenovelas, I actually did not have that much data. I had less than 100 megabytes. And it was actually just looking at the raw text spoken word data itself. That wasn't including things like sometimes there's cues in scripts that say something like, oh, 15-second pause with a dramatic stare to the side. So those weren't actually, those kind of nitty-gritty pieces of information I actually didn't have in my text that I was working with. So thinking about that I had a small data set and something that I wanted to have some ability to debug a little bit more friendly, let's continue on to my third requirement, which is basically how easy is it to start using a framework? And essentially, what I wanted was to get something that allowed me just to be able to bootstrap and get going, because I just wanted to know what it means to actually start working with text, start processing text, and actually start doing text generation. And all that to say that the one that won for me, notice my priorities? Keras? Yes, I opted to work with Keras. So what's really cool about TensorFlow is you can actually Keras you can plug in and you can use with TensorFlow, and you can do you can use TensorFlow and Keras quite nicely together. But on the side of how to make a telenovela script a bit more intelligible and more interesting, think of it this way. Maybe I can write an RNN model for each character that I want in my plot. So maybe like the David Hasselhoff, maybe I have 5 characters in the fight scene and I want a model for each of them. Maybe I look for similar sources of inspiration. So maybe I'm like, okay, I want telenovelas that have strong women leads. And maybe that's what I can use as the input for my strong woman lead LSTM model. Also, what we can start doing is weaving these models together, or maybe even having models based on categories. So long lost love, rom-com, things like that. Whoop. So all that to say, and I know this is a little bit of a cop-out, but yeah, text generation is hard. It's pretty hard. So creating a learned plot, sorry, I don't know if I'm going to come up with a consultancy tomorrow to take away all of Hollywood's jobs, but I'm going to try. So how can we do better? There's no surprise here. One, always validating your data. As I kind of said, there's a lot of time spent processing and looking at that data. So notice there's some strange characters on the right-hand side. Notice on the left-hand side, you get this character, the Latino lover, who's the narrator, which is a very strange thing to read out of context. But notice how, like on the right-hand side, we may include character names, but I had some text that actually didn't name the character, so that got a little bit more complex. So data validation is always a thing. And on that note, I'm just going to say to you all, if you want to add to my corpus of ever-growing telenovela data, you should add. I'm collecting it here, and it's a really fun process and really interesting. But yeah, text generation is difficult. We've probably all seen this one. The surprise here is deep learning is only as smart as you make it. So if you have more data to provide it, the better it is to use. So we've seen a lot of deep learning models get hacked out in the wild, for example, obscuring your face, because if it's learning that a human face is oval and your hair is pulled back, but then you have this wild haircut, if the deep learning model is actually learning that the relationship to a human face is a certain shape, and we're representing that data as such, again, we have to think about all these things and how the model is actually only learning the relationship that we provide it. So if you want to keep learning, I have examples of various resources here. Again, I will share these slides on Twitter. And that is the end of my talk. But as a total serious ask, if you do Oh Maria la del Barrio, like I was looking everywhere for it. I ordered it on VHS. We'll see if it arrives. Also, that gets into the place that I now need to have something that works with VHS. But that would be great. But if you do have any questions about this or want to kind of look at the repository and dig in and maybe help me make a more robust telenovela, come talk with me. I would love to see what we can create. Thank you.